recording. Okay, so, and then we also start the screen share for everyone here. Screen. All right, so very basics. How do we make a project in Unity? It's very simple. Um, so if you have installed Unity, you'll definitely have the Unity Hub. This is just a place where you'll see all your projects that you've started and that you're working on. You can also see all the different versions of Unity you have installed. So if you have two projects that are using different versions, you'll see them both installed here. And then when you go to your projects window, you'll see the versions are different. So for example, these two games here have different versions attached to them. So if I open up this one, it'll open up this version of Unity. So it'll open up this version of Unity. Very simple. The version I'm going to be using is this one, 2020.3.16 F1. Um, it doesn't really matter too much as long as it's, again, kind of like a modern version of Unity. So new project is super. Oh yeah, that's actually, I should mention that your might look slightly different. I'm using the beta down here. If you're using not the beta, which is what you install, it just might look slightly different, but everything's the same. So new project, super simple. We come over to the projects tab and click the blue new project button, and then you're gonna have a slightly different screen. You'll see like some templates on the top left, and then like a name and a location on the right. So we're gonna select 3D for this tutorial. Just you'll see it's a little box that says 3D. There's also 2D. There's also some other like templates you can choose. 3D is just gonna get us set up with a camera and a light and all the stuff we need. Then we can give it a name. I'll call this Cogs tutorial. You can give it obviously whatever name you want, and then put it in whatever folder you want. I think I have a Cogs folder in here somewhere. Maybe. I don't. I'll put it in here. New folder, Unity. So again, just put this wherever you want on your computer. That could be on your desktop. It could be on in your documents folder. Really, whatever you want. So we give it a name, we give it a location, and we selected the 3D template. It should be 3D by default, but if it isn't, you can just make sure you selected 3D. And then we can hit create project. Now this might take a little bit of time to actually start a project. It's gotta make all the stuff. So some people here had used Unity before, some people hadn't. Has everyone here opened Unity before? Just trying to stall while this makes the project. You can either say it or just type it. Has anyone here like never opened Unity before? And again, feel free to just type in BC Text Chat.
I just have a quick question.
Yeah, what's your question?
So you said that we had to download the 2020.3.16, but I think in the announcements,
Okay. Yeah, again, if the version is slightly different, like what do you have?
I have the .18 instead of the
That's
.16.
that's perfectly fine. The versions,
Uh,
for the most part, the changes, especially for like at the level we're going to be learning this, the changes are negligible and we're not going to notice them.
okay.
So if you do have a version number that's slightly different, as long as it's like 2020, even 2019 is pretty much going to be mostly the same. You just don't want Unity like 4. That might be an issue because at that point things are going to start to change. All right, so the project's almost created. Usually takes around minute 30. All that fun stuff. So when we get in, I'll just start talking a little bit about it. There's going to be a few windows that we care about. It's going to be in our center window, which is going to be our scene window. And again, we'll see that when it actually loads. We'll have the window on the right, which I'll be calling the inspector. We'll have a window on the left, which is called the hierarchy. Oh, here we go. It's opening now, hopefully. Let's move that over here. I can actually show off what I'm talking about. So here it is. Here's what Unity opens to. This is the default. Yours might be light theme. If it is, you can change it in the settings somehow. Worth a mention. All right. So this is our scene in the middle here. It's our scene view. So navigating the scene view is pretty easy. Kind of has like first-person shooter controls. If you hold down right-click, and then move your mouse, you can look around. And then you can actually, while holding down your right mouse button, so notice my cursor's little eye icon, you can use WASD to move. And it moves you forward in the direction you're looking, not forward like that. So you can move down, up if you look straight down, up. There's also Q and E to move down and up relative to the direction you're looking. So you can usually just figure that out just by playing around a little bit. WASD to move. You can use Shift to move faster, kind of like sprinting. And all of that while you're holding down right mouse button. All right. Also, another thing, if you hold down your middle mouse button, your your cursor turns into a little hand icon, and you can pan the camera around. Just another useful little tool for navigating your scene view. So, again, this is our scene view. You can think of this like your developer window into your game world. Here I have a few things that Unity has so kindly provided for me. I have a light, little sun icon, and the camera here with the little camera icon. So nice and easy. And then a vast empty plane of nothingness. So this is what you're going to see as the developer. This is not what the player is going to see. The player, if you come up here to this little like game tab here, click that. This is what the player is going to see. So like, what is this view, right? Where did this come from? You can tell it's the same world, but like, I can't move around or anything. And the reason is because the player sees the world through this camera. So anything that's not, in view of the camera, the player is not going to see. So as a developer, and we'll go over this more in detail, don't worry about it. If I put this cube here, right, and it's a cube, and this is, I don't know, some objective the player has to reach. But right now, my camera's not looking at the cube. So if I go into game view, this is what the player sees. They don't see the cube. So me as a developer, I can see the cube. Player's not going to be able to see that. So there's many ways I can change this depending on what my game is. If my game has a fixed like overhead camera and things are moving around the screen, maybe I need the cube to move onto the screen, and then the player will be able to see it. Alternatively, if I have something like a first-person shooter, maybe the player needs to actually turn around to see the cube. You can actually see a little preview right there. So it's always good to keep in mind, this is what you see as a developer. This is where you can create your world. This is where you can test your game, and we'll go over testing. And this is what the player's view into your world. So that's scene and game view. Any questions, remember, feel free to stop me. But I'm going to keep going. On the left here, we have what we call the hierarchy. So it starts out with a sample scene, which is just our scene. And we can think of a scene like a level in a video game. Scene's going to have all of the objects, all of the controls. It's going to, in a way, kind of hold all the scripts and everything that control one part of the game. So, for example, menu screen would be its own scene. You'd have all the UI, you'd have all maybe the animation, whatever, playing. And then when you hit play game, you'd transition your scene. You'd move over to a game scene where the actual game logic starts taking place and all that fun stuff starts happening. So we're going to work all in one scene, but just keep in mind that, we think of scenes like distinct states of a game. Theoretically, you can also use them for, in a more advanced sense, use them for like locations in an open world. But generally, you want to think of them like a level. If there's a loading screen separating two things in a game, that's probably like a transition between scenes is a good way to think about it. So we're working in our scene, which has a camera and a directional light. So these two things here were provided to us by Unity, and they might seem special. You got main camera, that seems pretty special, and a light, it's pretty special. It's going to give us light, but in reality, they're not. So everything in the hierarchy here. So for example, if I can make a new one, just a game object, and that actually kind of gives it away. Everything in here, all three of these, are actually kind of like the same thing. They're all game objects. So we have to talk about what a game object is, and most simply, it's an object in your game. That's the easiest way to describe it. It is the base of like everything that's going to be in your scene. It's a game object. So if I make a house in my scene, it's going to be a game object. When I put the player in the scene, it's going to be a game object. When I put the player's gun in the scene, that's also going to be a game object. All these things are going to be game objects. So in reality, this main camera that the player is seeing the world through isn't actually that special, because all it is it's a game object with a camera component. And if I were to tag this one with main camera, probably eventually complain because now I have two main cameras. But I basically just, it also has an audio listener, but I basically just recreated, this camera here that Unity gave me with this one. So this main camera is not special. No game object in Unity is really special. What makes it special is not like, they're all game objects. It's the components that they have. So we have the hierarchy on the left here. That's going to show us all the game objects in our scene. The right here is the inspector. So it says inspector at the top. And depending on which game object you click, or in the hierarchy, you can either click in scene view or the hierarchy, you're going to change what you're inspecting, the game object you're looking at, the properties you want to change. So let's make a cube real fast. So in our hierarchy, if we right click, we're going to get a menu. If we go to 3D object, we can make cubes, spheres, capsules, cylinders. These are really great for debugging. You might need a cube to represent your player character while you're waiting for art. Or you might need a cube because you can scale it to make a wall. Super easy. So we'll make a cube. And with this cube, if we now look in the inspector, we see a few things. So it has a transform, and I will mention that every game object in Unity has a transform because a transform is your position, rotation, and scale, which is something that you need to exist in the world. So everything in this scene exists in the world that I'm looking around in right now, and so it needs a position. Um, Even if I create an empty, it's basically a game object with no components, there's still one component. It's the transform component. So this component is in every game object. If you look at every one of these has a transform. It's really just position, rotation, and scale. It's exactly what you see here. So it's where the object is in the world. Looking back at our cube, we have transform. Again, we have to have transform. But we also have the three other ones that, again, make it special. They differentiate it from the main camera. We have a mesh filter, which basically just defines the vertices of the cube, basically just telling it to be a cube. If I were to change this to something like a capsule, notice it actually changes into a capsule because I've just changed the vertices that define, what this cube looks like. I could change it into a cylinder. I can change it into a sphere. We're going to keep it a cube for now. There's also a mesh renderer, which just renders the mesh to the screen. So for example, if I wanted to stop rendering something, I could just turn this component off, and now I have a cube that's not rendering to the screen. It's not rendering the mesh. The screen box we'll talk about more a little bit later. It's a collider. We use it for physics. Basically, it defines the hitbox of the cube. So when I create a cube, it gives me a nice sized hitbox. Notice it's pretty perfect. I could make it bigger if I wanted to. Click these tiny little squares and drag it out. And now this is the hitbox of the cube. This is going to be more of a game design thing. When you're thinking about, for example, your player hitbox. A single player game might actually have the hitbox be slightly smaller than the player, just to give the player more of a sense that they're dodging bullets and they feel good at the game. A multiplayer game might have hitboxes slightly larger, just to account for network lag and bad aim of the other players, and it just feels more fair in that scenario. So that can all be a game design part when you're thinking about your hitboxes. But again, these are all components on the right. That's the important part of this. They're all in the inspector. And again, it's what makes this cube special. It's what makes it a cube, really. I can remove this component, and now it doesn't have a collider. So now I said collider is used for physics. This can't really interact with any physics things. Things will phase through this all day. If I were to remove the mesh renderer, I am left with basically nothing. Technically, it has a mesh assigned to it, it has a cube, but it's not actually being rendered. It has this information. It knows what it should look like, but it's not actually drawing it. So that's it. Then if I remove this component, I have an object called cube, and you can change this. This is all up to you. You can name this whatever you'd like. I have an object with a transform, and this on the right here looks mighty similar to if I were to just create an empty. So again, I just really want to hammer in the point that every game object here is the same thing. They're all game objects. It's just the components that we attach to them. I can also create a cube from the ground up by just attaching those same components we took off. So if I add a mesh filter, and then I give it a cube, and then I add a mesh renderer, tell it to render. It's pink right now. We'll fix that later. And then last, we can give it that collider, box collider here. And now basically I've recreated the cube. The reason it's pink is because the material that we're using is no material. Think of that like a texture. There should be a default material we can use. Default material. There we go. And there we go. I've just recreated the cube. So um, I've just added the components I need to be a cube. Now, talking about components, we have, the ones Unity gives us. So we have mesh filter, and we can supply our, yes, the stream is being recorded. So this will be available on YouTube at some point soon, hopefully. This mesh filter here, basically it's a cube. We can provide our own meshes. So for example, if we have a spaceship, we can provide our own mesh, and that will, change the shape of this cube. We can also change, for example, the material here. So I use default material. If I created my own material, which we'll do later, I can, drag it in basically, and then I'll watch this cube change its material. Material again is like texture and lighting and all that stuff. And then box collider, I can change stuff. Physics material, I can change the size, the center, the scale, all that fun stuff. We're going to do a lot with box colliders and physics, either today or maybe next time. I'm not sure yet. So, again, Unity provides us a lot of components. So far, these are all like Unity provided components. You can see them all here. A bunch of physics stuff, just audio stuff for audio listeners, chord filters, audio sources. So if you wanted something to play audio, you put an audio source component on it, and then you can define like the clip of audio you want it to play and all that fun stuff. And then actually, if you notice, our camera has an audio listener. So if we attach our camera to our player, let's say like first person view, the camera's kind of like in the player's head kind of thing. It will actually listen for audio from all the audio sources around it, and it'll play that to the player. So super easy way to do audio. Little sidetrack there. There's a bunch of other just ton of components. Again, this is what I mean by when I say I'm like trying to give you what you need to know to, do something in Unity. Like follow a tutorial. I can't teach you all these components. There's simply just too many. But if you ever want to figure out what one does, or you're trying to get a specific thing, it's useful to know exactly what a component is and how you can use it. So, is there another? Oh, we could add a line renderer, for example. So here's a component, a line renderer. All it does is it draws a line behind our cube. So it's the default material. So this one has a lot of stuff. It's a line renderer. Again, it's a component. So it's not really, what it does is basically draws a line behind something. And so if I want a line behind a bullet, for example, a bullet trail, maybe I could just take my bullet game object somewhere, put a line renderer component, mess around with it, mess around with all the properties. Notice I can change the width of the line, I can change the color. There's no material right now, so it's just pink, but do all that fun stuff. You can even give it like a texture, tell it to do all this stuff. And then you'll have, all of a sudden you'll be drawing a line onto your bullet. And you did that just by adding a component. So it really depends on what the component is. Now, right, let's imagine I want to make a player, right? I want to make a player, moves around, first person, WASD, whatever. Or let's do third person, even easier. WASD. Question is, how do I do that, right? So maybe your first instinct might be hit add component, right? Because I just said components are, what controls everything. We want to make our cube into a player. How do we do that? Maybe there's some player component. Unfortunately, there isn't. So nothing here. If you look up controller, there's a character controller, but that's not really what we want. That's not going to give us like WASD movement and stuff. So the question is, how do we move around how do we move around our little character? I want to move around our cube with WASD. And there's no component right now that can do that for me. And this is where the fun coding is going to fit in. So, last window we need to talk about is on the bottom here. So we have our project window, it's called. And here you're going to be able to see all of your assets. So real quick, assets are resources that your game's going to use. In here, in your assets folder, it's going to be all your scenes. So for example, you might have your main menu screen, your game scene, your game over, like end screen, all that fun stuff. You're gonna have materials, and we'll talk about materials soon. I'll show off some basic stuffs of materials. We're also gonna have scripts, which is where we're getting to next, just the very basics. Moving stuff, basically scripts doing whatever we want. You're gonna have a bunch of other stuff in here. All your models, your textures, all that stuff that's gonna basically be resources for you to use in your game. So for example, you might have a model of a spaceship that you drag in, and then you apply one of your materials to it to make it look like a spaceship and not like a block of tofu. And then you can attach a script to it as a component, and then it will move around like a spaceship. And all those things you either create before, or you create in Unity, or all that fun stuff. Real quick, worth mentioning, if you use any art programs, like for example, I'm gonna use Blender because it makes 3D stuff. To get Blender into your Unity game, it's actually really simple. You would just export to a file type. I think Unity likes FBXs, but this is specific on the program you're using and all that stuff. You can look that up, figure out what you need to export, like what file you need to export to. But you export it to a file, let's say an FBX. And then it's as simple as dragging that file into your assets folder. And then it will exist as a resource to your project. So if I had an FBX to drag in, I would drag it in here. And then I would see it here, and then I could drag it into my world, and it would create that. Maybe I can actually see if I have. I think I might have. Oh, it's in a RAR. Okay, I'm not going to do that then. But yeah, you could just drag it in, and it would do all the magic for you. Any questions at this point about really what components are, or anything else? Pause for a little bit. Again, feel free to type in VC text chat or just unmute and speak. All right. If there are no questions, I'll continue. So we're going to talk about the basics of scripts because they're a very nice, easy component. Well, not easy, but they can be easy component. So whenever you write a script in Unity, it's going to be added onto as a component of our game object. And again, components are what make an object unique. So in this case, we want this cube to be our player. Let's actually name it player. Let's give it a name. Let's get that capitalization correct. You can do this just by clicking the name at the top and giving it a name. Just so that in the hierarchy on the left here, we know what's what. So we have our player. Let's make it move around. So we're going to add component. And then instead of selecting something here, because none of the options in here are going to give us WASD movement, you can select the option at the bottom here, new scripts, and then give it a name. Naming conventions, pretty similar to like Java or any other programming language. No spaces, can't start with a number, stuff like that. C#, or this is the same as in Java, but they like you to start with uppercase letter for class name. Not like it matters too much, but you should do that. So for example, I would call this script player controller because it does, as the name would imply, controls the player. No space there. If you put a space, it is going to throw an error. It's going to be kind of ugly. Player controller. Used camel case, no space at the beginning or end, Give it a name and you can hit create and add. And that'll create a little script for you here. You'll see it represented by a little C# hashtag there. All right. And then also, if we look at our player, we did add component, if you remember. You'll now see it as a component in the inspector. So let me just collapse all these. You'll see we have player controller here. So what this means now is that player controller is going to do its thing on our player. So in the same way that box collider is going to be a box collider on our cube, player controller is going to be a player controller on our cube. And it might not seem like it. It might seem like these are like some special things, but really in the end, these are just like C# scripts. Like the mesh filter, it's just a C# script. The transform is just another C# script. Box collider is just yet another one. So what we're writing here is really no different from what's up here. It's just that these ones are general enough that Unity has decided to provide them to everyone. The ones we write here are going to be more specific per game. And you might think oh, WASD movement seems like something that would be pretty specific, but I mean, pretty general for everyone. But if you're making a top-down or point-and-click adventure in Unity, you're not going to need that. So it's something that they don't give us, but it's luckily easy enough to make on our own. So at this point, so if you are following along, you can try to double-click your player controller script. It'll be in your assets folder. So I'm just going to double-click it. For me, it's going to open Rider, because that's like the preferred IDE I have. If you, it might open Visual Studio. It also might open. Actually, I think it'll only try those two. Um, so here's Rider open. This is similar to IntelliJ. It's my preferred IDE. It might open Visual Studio. If it doesn't open anything, I'll mention this because this is a little annoying sometimes. On Windows, if you go to Edit Preferences, and then on Mac you can just hit, go to the top bar, click Unity, and then Preferences. We go to Preferences, and then we go to External Tools tab here. Our external script editor, the first option. You'll notice I have a few things. I have Rider, which is what I have selected. I have Visual Studio Community. That might be installed by default. I'm not quite sure when that gets installed or not. You might have that. Visual Studio Code will show up if you have that installed. You might also only see Open by File Extension and Browse. This is just telling Unity like what program to open to edit your scripts in. You can't use IntelliJ because it is C#. So if you want a alternative to IntelliJ, you can use Rider. Really lightweight alternative is VS Code, Visual Studio Code. You can install it in like actually 5 seconds. Just look up Visual Studio Code. Yeah, but you're probably gonna want some script editor. If you don't want something too heavy on your computer, I would really recommend Visual Studio Code. It's definitely the lightest weight. I'm not too much of a fan of Visual Studio, but it might come with your Unity. And there's also Rider if you like that. So all the code is going to be the same depending on whatever IDE you're using. I'm just going to look a little different. Colors are going to be a little different, but all the code is going to be the same. All right. So we're starting with our player controller script here, and our goal is really simple. We want to look at input, and we want to make the player move forward, left, right, back. Really simple. Not going to interact with anything, just going to move. Right now, we even have our cube kind of sitting over the void, so there's nothing really to interact with. But all we're going to have them do is forward, left, right, back. So we're in our player controller script here. This is similar to extends, or it's the same thing as extends in Java, and monobehavior. Monobehavior is basically the base class for all your components. Basically, it just defines that, hey, this class is a component, and so it can be attached here. Or, sorry, attached here. If you were to remove monobehavior and make it not extend monobehavior, you would not be able to attach it as a component. It wouldn't be a component, it would be a script. It's a base class that basically defines it as a component. And it is useful because it gives us a few different functions or methods we can use to help us write some code. So the default Unity like template for C# scripts probably looks something like private void. I know they start you out with a void and start and update. So you might something like this, minus the throw exception, and update. And then you'll probably have some comments kind of explaining what each one is. If you don't, you can probably add these two. These two are the more useful functions that we're going to need for writing our code here. So start, this first one here, is called before the first frame update. That's what the helpful little comment might say. You can think of this like when I hit my play button on my game, or when I start my game, start method is going to be called once. So this is a really great place to initialize variables. It's a good place to move things to their starting positions. That's pretty much what it's good for. Maybe fill a list with random values if you're trying to like make a bunch of random asteroids in a field, What's important about it is that it's called at the very beginning of this script's lifetime, which for the most part is going to be the beginning of the game, or the scene, sorry. And then only once. So this is only going to be called once, unless you, you know, delete the game object and make it again. Then it's going to be called multiple times. But it's called at the beginning of the game object's lifetime. So when I hit play, this is kind of already in the scene. So its lifetime is going to start, and it's going to run the start function here. We'll get to instantiating later, but let's say my game's running. Let's say I have a script on a bullet, right? Pretend like this is a script on a bullet, and the start function sets its velocity or something like that. Every time I spawn in a bullet, which has whatever bullet script on it, it's going to run its start function. So every bullet will have its own little bullet controller script, and then every time it'll call its start function, which will set its velocity to whatever it needs to be. So just worth a mention, player controller is probably like you're not going to use it on multiple things. Like you really only use it on the player, which usually there's only one. But scripts are definitely reusable, just like any class in Java. Now we never make one. Like we'll never type something like new player controller. Like you'll never type this, because it actually won't let you. Or yeah, but that's not the error. But it won't let you because it's supposed to be a mono behavior, which means that basically the new player controller, like you would in Java or even in C#, happens when it's attached to a game object. So when this script is attached to the game object, that's when a new one is created. So we don't have to worry about like instantiating specific scripts. We only have to worry about attaching it as a component. So adding it onto the right here basically, or just creating the game object as a whole that already has that component. Then it will create a new object of that script. We never have to actually do that in Unity. And this is specific to mono behaviors, but that's what you're going to be working with a majority of the time. So for example, in start, let's give a good example of it. Let's print out a message, right? The most useful debugging tool. For Unity, it's debug.log, and then the message. So instead of system.out.println, you can just do debug.log, or you have to do debug.log. Then our message, we'll just do hi. So what's going to happen now is I have this component, and when it starts, it will print out a hi message. So moving back to my game, it'll compile everything. Notice that the component is on the player. If I were to remove this component, and it's not on any of the game objects, if I hit play and then watch my console, nothing happens. Now what's supposed to happen, let me show you before I explain. I put this component onto my player controller, and now if I hit play and go to the console, there's a message there, hi. That's the message I wanted to print out. The reason it didn't print out the first time is because this component was not on, or the script was not a component of anything. This script prints out the message on start. But if it's not attached to any game object, so if it's not a component of any game object, it's not going to run. The script does not live on its own. It lives as a component. So if it's not a component of anything, it's not going to run. So that's something that might be a little weird. This is not, don't think of this like, it's not a game object. This is a component. It is part of a game object, and it will do things to and using the game object it's a part of, but it will not do anything if it's not attached to any game object. So that's something that, depending on you're familiar with programming and stuff, might be a little hard to wrap your head around first. But if this isn't attached to anything, nothing's going to happen because it's not going to run. It needs to be a part of a game object to actually run. So printing out hi is cool, and we saw it printed out once. It printed out when I hit the play button. And by the way, I didn't really mention it. This is just a way to test your game. When you hit play, it'll kind of like simulate the game in the game view here. So you notice it switched over to game view, and then this is what the player sees, and then yeah. So this is a way to simulate your game. All right. And if you have any questions about anything so far, feel free to interrupt me. We're going to move on to update next. So update is called every frame. So that's a lot. Every frame in a video game is going to be 60 frames per second, 144, depending on what you're targeting. Um, so your update is basically where kind of like the meat and potatoes of your game is going to happen. So in our case, we want to move around WASD. There's two steps to that. One is getting the input, and two is moving the player. We want this to happen every frame because if it happens, because that's a frame you can think of like one game, one tick of the game. We want every tick. I'm gonna use tick. Every frame really. We want to check the input, and then we want to do whatever we need to do. Right. We don't want to put something like this in start because start runs once. So it will check if we're holding down W and then move us, and then at the very beginning of the game, and then never run again. So update is where all this like fancy stuff is gonna happen. Um, One thing I'm gonna mention because I have seen some people try this before, not necessarily in this club, but like I've seen people try this before. Don't put loops in your update method. Like you might have a loop to like loop through a list, okay, but you don't need a loop to check for input because update itself is a loop. It's being called every frame. It's being called every frame while the game is active. You don't need any loops in update. I have seen that before, and I can understand it's a little confusing. Think of update like a loop that's running. It is a loop that's running every frame. Every frame update is called. So you don't need a loop to make sure you're always checking for input. It's already happening if you put it in update. Let's do the example. So I'm going to assume everyone has like some basic familiarity with programming. I'm going to assume like if statements and like, transform dot translate, which I'll explain, but like, using functions of a class. If you don't, stop me, but that's the assumption I'm going off of. So if anything is unclear, let me know. So we're in our update function, and again, this is called every frame, and we want to move forward when we press W. That's going to be our first goal. So first thing we need to do is, are we pressing W, which is a conditional, which means it's going to be an if statement. So remember if, and again, this, and by the way, if you've taken Java, it's going to look very familiar. It's basically Java. So if, and now, are we holding down W? So this is a Unity specific thing. I'm going to teach you the way to do it that's super easy. There's a way to do it that's a little bit more complicated, but like better. So it's kind of like a trade-off. This is the super simple way. It will probably work in most cases, but if you ever are curious about the input system, it's called the input system. Feel free to ask, and maybe we'll use it in one of like the tutorial games down the line or something. So just to get simple input really easy, if input dot get key, and then we give it a key, so we're going to say key code dot w. So I'm going to break this down real fast. Input is just an input class that kind of is going to allow us, that Unity provides, that just has like an API for all these different types of input. Get key is specifically going to check if the given key is being pressed currently on the keyboard. So it'll return true if the key is being pressed and false if not. And then keycode.w is just saying the W key. The reason we use key code is because get key actually takes a key code, but which is basically an integer. Just because obviously computers like numbers, not W. They want to know it's key 127 or whatever. So human readable like this. So this will return true if we're holding down W, and false if not. If you have any questions about this, stop me. And it will do this every frame. So let's do a little test here. W is pressed. All right. And now it's going to refresh, come back to Unity here. Awesome. Remember, my player controller is on my thing, so it'll run. Hit play, and we're going to watch the console here. Nothing's going to happen. I'm going to press W, and our log is going to be spammed. So it stopped, and now if I hold down W again, log spammed again. And the reason it's being spammed, I mean, all this happened in the same second. Hold up. This through, all this is in the same second because we can check the stats here. We are running like 300 frames per second. So it's happening 300 times a second. So that will be a problem for something later, which we'll have to get over. But clearly this is working. When I hold down W, W is being, I'm getting the message, W is pressed on my screen. So now we just have to convert, instead of a message to the console, which the player will never see, let's convert it to movement of the cube. So let's reload. All right. So here's our cube. I'm just going to mention the coordinate system real quick because we're going to need that to move. Unity is primarily a 3D game engine. So we have our x, our y, and our z coordinate. X. So let me explain it this way. The way that Unity likes to represent the different axes is that z is forward and backward. So positive z, so positive z is forward in the world. Moving positive x is moving to the right, and moving negative x is to the left. And then finally, the y is up and down. So you don't necessarily need to abide by this, but this is the way that Unity really likes to think of things. When you say move forward, and you'll see we actually use the word forward, it's going to move positive on the z. So if I had my whole game world set up this way, which notice is along the x-axis here, this is the x-axis. If I had my whole game world set up like a nice long stretch here, and I said move forward, my guy's going to move this way. So it's something you want to keep in mind. Forward is z. That's kind of like, again, it's like the right-hand rule in physics, if you're familiar with that. It doesn't necessarily mean anything. It's just the way that we do it. It's the way that it's like the common convention. Z is forward. Also, to make things even more complicated, is each a cube. If we were to rotate it, so let's rotate it a little bit, and then switch it to local. Now it has its own forward. So at the top right is still the global forward. The global forward is along this line here. But this cube has its own forward. And, oops, that's 2. I'm going to hit W, E. If I keep rotating this, you can see that this cube has its own forward. This is actually pretty useful, because what this means is that we don't need to keep track of like the angle that the cube is at. What we can do instead is just say, hey cube, move forward, and it will move forward along its own axis forward. And you can think of this, in real life. Imagine walking around on the street, and you say turn right. Your right's relative. If someone was upside down, their right would be the other direction. So you turn to your right, and then someone says, "Hey, move forward." You're gonna move, forward relative to you, not forward relative to them or the world or whatever. So, for example, real quick, rotating our player would be something like, just rotating and then moving forward again. So this is forward now. That can be a little bit confusing. If you have any questions, let me know. All right. So, yeah, so our goal, again, is move forward. So forward is positive on the z. You can see the position change. It's positive on the z when I move forward. Or rather, it's forward when I move positive on the z. But come here. Now what we have to do is move forward, right? All we have to do is add to our z coordinate. Again, a little bit of physics. Motion or velocity is change in position, right? So if we want to move in a direction, we want to change our position. Position's right here, x, y, and z. Let's do that. So come here. If we're holding down W, now here's where the fun part begins. Transform, lowercase t, is a variable. It is the transform component of the game object that we are attached to. So this player controller component is attached to my player cube. And remember, everything has a transform. So when I say transform lowercase t, I'm getting the transform component. I'm getting this transform component. I now have access to it, to all of its functions and all of its members and all that stuff. So transform dot, and you might have some nice autocorrect here, or whatever it's called, IntelliSense here. The one we're going to want is translate. So translating, is moving an object in space, like sliding it. You might remember that from geometry. It's not rotation, it's not reflection, it's translation. It's basically sliding it in space, moving it from one coordinate to another. And in this case, translate, we're going to give it a vector 3. Now, a vector 3 is pretty simple. It's just basically 3 coordinates or 3 float values. What it represents is um, dependent on the interpretation of it. In some cases, it might be a coordinate in the world. In our case, it's going to basically be the delta. It's going to be how much we want to move. So let's do it this way first. New vector 3. We're making a new vector 3, which again I said is. Can we take a look at that? Or actually, no, if we can look at it. We can't really. Also, it's much more complicated than it seems. But basically, we give it 3 values, an x, a y, and a z. And our translate function here is going to read this vector and move us however much on the x, however much on the y, and however much on the z. So if I say something like this, and we need to, oh, that's good. What's going to happen is if we're holding down W, we're going to move by 0. So actually nothing's going to happen, but this is perfectly valid code to write. Now, I said we wanted to move forward, right? I said we wanted to move 1 on the z. So let's do that, or positive on the z. So let's try something like this. Put a 1 there. And what's happening now is we're translating, right? And again, this vector 3, you can kind of think of it like a delta. We're moving 0 units on the x, 0 units on the y, and 1 unit on the z. So this is going to work. Let's bring ourselves back to Unity here. Let it load, let it reload. All right, hit play. And now I'm just going to tap W real fast. Yeah, so I'm tapping W right now. You can see I'm just disappearing into the distance. There's a little cube guy going real fast. Let's take a look at what that's like in scene view. Here, I'm going to tap W and then go back to scene view. You can see I went really far. I probably held down W for like 0.2 seconds. So we went really far, and notice we went to C32. So I actually held it down for, I don't know how many frames, but not very long, because if I'm running around 200 frames per second, this is like about a tenth of a second. So, and I kind of went flying. I think a general rule of thumb is that 1 unit in Unity is about a meter-ish. It's kind of up to you. I think that's kind of the generals. Like, that's a meter, or maybe a foot. Up to you. So our guy's moving too fast, because remember updates called every frame, and that might be 200 times, so it means in 1 second we're moving 200 meters, right? We kind of want to keep units small in Unity. We want to move reasonable amounts. So I like to think of them as meters, so that that when you're 32,000 away from the spawn, like that's a lot. So let's make a variable to help us with this issue. Variables are super easy. Public speed, we'll call it, or sorry, public float speed equals, we'll set it to like 0.3, something like that. We're going to need to adjust it later. So variables in Unity or in C# really, are the same thing kind of as in Java. Float, we use floats instead of doubles, I'll just mention, because they're more space efficient. If you use doubles everywhere, you're kind of wasting memory. You probably don't need the precision. So we like to use floats. If you do need the precision, feel free to use a double. But floats are really preferred because the chances that you need, what is it, like 14 significant digits or something? I don't know, some amount, is unlikely. So use floats whenever possible. So we're going to have our speed here. And this is just a scalar value that we are going to multiply with the vector. So this is kind of like vector math, kind of like physics, really, the basics of it. We have a vector, 0, 0, 1, and we're multiplying by some scalar value. So we just multiply every component of the vector by that scalar value. So we end up with 0, 0, 0.3, because 1 times 0.3 is 0.3. Yeah. And another neat thing. So you might notice every time I hit save, right? So now if I open Unity again, it has to load. That's really annoying. Now imagine if I had to come in here every time and then I'm like, oh, it's still too slow. 0.4, right? Now is this good? I have to save it, then I have to open Unity, then I clicked Unity, I'm waiting for it to load. There we go. And it's going to get longer as you have more stuff. Luckily for us, we don't have to do that every time. If you have a public variable, and there are ways to do it with private variables, but public is just easier. Public float speed, right? It's public. If I open up the inspector, notice that it has appeared here, speed. And it's still 0.3, that's okay. I can change it to 0.4. I can just type in 0.4. And now the speed is 0.4. Here, let's show an example. Go to we'll go to a very small value because our guy was moving real fast. So we'll say we're moving 1,000th of the original speed. And I can see I am moving. You can watch my progress appear, albeit very slowly. Let's speed that up a little bit. I don't actually have to exit play mode. I can just kind of like edit it right here. And you can watch the speed changing. See, like that seems like kind of reasonable. I could slow it down even more. Yeah. So here's the thing. I can edit this variable now. Even as the game's running, I can edit it completely in the Unity editor. So if I want to change it, if I want to tweak it, I do not have to go back into the code to do that. And that makes my life and your game designers, everyone's life, just a whole lot easier. Now, there is one caveat I'm going to mention. The original value of this was like 0.001, and now it's 0.13. And I'm like, yay, I found the value I like. This is the perfect value for my movement. Let me exit out of play mode. And it's been reverted. So anything that happens in play mode, any of these variables changing, is going to get reverted when you exit. So this is overall a good thing. You might not realize it because when I move, notice these variables up here are changing. I wouldn't want to exit play mode only for my cube to stay there, right? Or if I have enemies patrolling, I wouldn't want to exit play mode only for them to, end up right where they ended up at the end of the game. I want them to go back to the starting positions. So it's overall a good thing, but you do have to be careful that while you're in play mode, while this button is lit up, you don't edit any variables that you're not prepared to be reverted. Now, what you can do is, play around in play mode, find the right speed, and then remember it, copy paste it, exit play mode, and then when you're not in play mode, put in the right value. Now this will save. So now if I hit play, it'll be 0.13, and when I exit play mode, even if I change it, it'll still be 0.13. But yeah, that's one thing to really keep in mind. I'm going to breeze over this real fast. You can probably watch the recording. One thing you can do to help with this is go to Edit Preferences, and then go to Colors, and then Play Mode Tint. It's the fourth option. Change this to any color, really, and you'll notice that your Unity editor, when you hit Play Mode, probably looks the same. Mine goes purple, so I know when I'm in Play Mode. The reason I do this is because I have many times had the issue where I put myself into play mode, and then I recognize a problem, and then I forget I'm in play mode. So I edit all my scripts, and I start editing values, and then I go to test it, and I come up here, and I'm like, oh, I was in play mode the entire time. So all the changes I just made are going to get reverted. So that play mode tint is very useful. Again, it's just edit preferences, colors, and then play mode tint. So it says something bright that you'll recognize as in play mode. All right. So our movement's actually almost done. We can pull W and move forward, which is a good start. But there is a problem, and I'm going to demonstrate that by hitting play, and then opening up stats. And I want you guys to watch the FPS number, which is chilling at, 300-ish. And it's 300-ish, right? Now, I want you to imagine, we're going to use our imagination from this. I hit a lag spike, right? I go from 300 frames per second to 3 frames per second for, let's say it's like a 2-second lag spike. I don't know, something happened, something catastrophic. If I'm moving, and let's simplify, I'm moving 1 unit per frame. That means that, while I'm running around 300 frames per second, I'm moving 300 units a frame. But then I hit the lag spike. For the next 2 seconds, I'm moving 3 units. 3 units per second. So I go from moving 300 units per second to moving 3. Which means that for those 2 frames, I will move a total of 6 units. 2 seconds. Sorry, I'm getting confused. 2 seconds, you'll move a total of 6 frames. Or 6 units. But for the last previous however many seconds, I was moving 300 units every second. So basically what I'm saying is that when you're FPS fast, you move fast. FPS slow, you move slow, which is a bit of an issue. We like to smooth this out so that no matter, even right now I'm running good FPS, but it's fluctuating. You can see it kind of going up and down. That's natural. That's just going to happen. You see it's fluctuating all over the place. And while it might average out and not be a problem, if there's lag spike, it's going to be a problem. So let's fix that. And the reason we fix that, we're going to do a little bit more kind of math, fun. Just kind of want to explain the intuition behind it. We have a vector 3, and this code right now is saying every frame, let's ignore this, every frame move, let's even ignore this, make it really simple. Every frame move 1 unit on the z, right? That's pretty self-explanatory. Every frame, translate, move 1 unit on the z. So if I'm running 300 frames, I'm moving 300 units. Again, the problem with that is that frame rate changes. What doesn't change is time. Well, time is going to be pretty consistent in our game. 1 second is 1 second no matter how many frames occur. So what we want to do is take that FPS, basically convert it to seconds, and then we can deal with it. We don't have to do anything to update, but what we can do is add a little factor here. Product, not a product, I don't know, things you multiply. That's going to be time.delta time. So what is time.delta time? Time.delta time is the time since the last frame. So basically, if let's say I'm getting 1 frame per second, awful computer, time.delta time is going to be 1 second, because when I get to frame x, it has been 1 second since frame x minus 1. When I get to frame x plus 1, it's been 1 second. It's been 1 second since frame x. But I'm running really high frame rate. Let's say I'm running, 100 frames per second. The next, frame 2 is going to be 1/100th of a second after the previous frame. So basically, the relationship between time.delta time and frame rate is that as frame rate increases, time.delta time decreases. And as time.delta time, as frame rate decreases, time.delta time increases. Basically what this is doing is turning this movement from per frame to per second. Time.delta time here. Because this is what, frames per second, and then we're doing like seconds per frame. I don't know. It's dimensional now, something. It ends up, I don't remember off the top of my head. It's basically turning this into seconds. So before this code, if we had, it's really hard to see because we're running really high frame rate, but if I were to hold W, every frame, we would see it moving up by 1. If I do times time.delta time, save, open up here, wait for it to load. Unfortunately, we can't help public variable help with this. Let's watch this z value right here because this is what's moving. And you'll notice it's 1, 2, 3, 4, 5. It's 1 per second, more or less. Averages out to 1 a second, which is going to be much more stable because no matter what the frame rate is, basically, even if you have literally 1 frame a second, that means that in that 1 frame, it's going to move 1 unit. So if you have 1 frame per second, it's going to move 1 frame or 1 unit. Perfect. If you have 60 frames per second, every frame is going to move 1/60th of a unit. So if you have 60 frames per second, 1/60th of a unit, that's 1 unit. Perfect. So this basically just smoothing out our movement. You want to use time.delta time almost anywhere you have a repeated movement or repeated rotation, repeated something in your update function. Keyword there is repeated. We'll get to it when we talk about jumping, which might be next week. When you hit spacebar and you jump, that's going to be a one-time thing. That's a one-time you jumped, right? You're not dealing with that anymore. You don't want a time.delta time there. That's something that happens once, like the jump. And then while you're in the air, we're going to let physics do the work, so we don't need to worry about that. No time.delta time there. Now movement, it's happening every frame repeatedly. Let's throw a time.delta time on there to make sure it's not frame rate dependent. That's what this is, making sure it's not frame rate dependent. So at this point, we can reintroduce speed. It's going to tell us it's inefficient. Don't really care. So now Let's wait. Notice our speed's still here. And what's nice about time delta time too is now we have like an easy understanding of what this number is. It's how many units per second. So it's moving really slow. Let's change this back to 0. Let's change this to 5. And now let's watch this number in the top. Notice it's going about 5 per second. 1, 2, 3, 4, 5. 5 per second approximately. 5 units. It's a lot easier to understand than 0.13 units per frame, which again doesn't really make any sense. It's unless your frame rate is locked and you're guaranteed it won't go lower, then you could not use time to delta time. But in almost all scenarios, you want to use this time to delta time. Makes it per second instead of per frame. All right. Any questions about that? Feel free to ask. Last thing we can do is just a little convenience. I wrote out here vector 0, 0, 1, which means 0 on the x, 0 on the y, 0 on 1 on the z. Vector 3 has some convenience objects for us. One of those is forward, which is the same thing I wrote. So you notice it says here shorthand for writing 0, 0, 1. This is a kind of almost a better way to read it because you know what this means. We know what forward is, and then we can translate it in our mind to that's positive on the z. Basically just the forward unit vector. There's also, up, down. So down would be negative on the y because we said up is positive on the y. So this is 0, -1, 0. All that fun stuff. Do forward. Now Ryder's complaining. What does it want? Okay, cool. Multiply the two scalars first, then the vector. All right. So at this point, I'm actually going to move my camera a little bit because I realize the angle's not great. So let's grab our camera. And we can move it. I actually never mentioned this. I probably should have. You can move objects around just by, like, in scene view, just by dragging the little arrows. You can rotate it by clicking the little 2 arrows up here, the little circle, and then dragging the circle corresponding to the axis you want to rotate on. So maybe that's actually worth mentioning is that the colors here are like standard colors. So this green is still the y-axis. It means you're rotating around the y-axis. So if you're trying to figure out, like in code, how you want to rotate this player to make him look around, rotating on the y-axis is like left and right rotation. So it makes it a little easy to figure out. So this is rotation. You can also do some scaling, which is on the cube. It's this one. Drag it up on an axis. You can also select this white box in the middle that makes the whole thing bigger. Does all 3 at once. These are just the tools to help you design your world. Should have mentioned them earlier, but I didn't. So here we are. There we go. So we can move things around. We can rotate them. I can rotate the camera. You can even see a little preview of what's happening. And we can do the same with the cube. And then you can also scale it. That'd be useful for example, let's say you wanted to make a floor. Boom, floor, right? Super easy. I just made a cube into a floor. Now we don't want a floor, we want a player, so we're gonna leave it like that. All right, gonna hit play now. And I've reintroduced the speed variable. I have time to delta time. Let's make it bigger because it's really small. There we go. There goes our cube. You zoom in. Slow it down a little bit. There we go. I can change this a little faster, and there he goes. And I said forward here. And again, this forward is relative to the player. So like if you rotate the player, he's still going to move to his forward, which is usually what you want. I think you can say like false here or something. There's some way to specify you want to move forward according to like the global coordinates, but in our case, we're okay with this. All right, so we're almost done. One final thing we need to do is get it working for the other 3 keys on the keyboard. Luckily, that's pretty easy. We can copy and paste, and then we need to change 2 things every time, each of these blocks. One is the key we care about, so in this case, let's do A next. Right? A is moving left, and because we used, the kind of semantic naming here, we can actually just change this to left. Awesome. And now let's change this to something like S. Right? And then instead of forward, let's move back. It's not backwards, by the way, it's just back. And then D, instead of, forward. Let's move right. Here's what the final code looks like. And then we open up Unity again. I'm going to move our camera back. Here's a little fun little trick for free. If you get a nice view in your scene view, so for example, let's say I want to like look kind of top down on the player at a little slight angle. I could try to like finagle the camera to get it up here and rotate it correctly. Alternatively, what you can do is get into this position, which is nice and easy because you can fly around and adjust yourself. Select the camera, go to Game Object, Align with View, or Control-Shift-F. And when you click that, the camera is now seeing the exact same thing you are, which is just very helpful. So you can see in the preview that looks mighty similar. It has moved the camera, so basically it's at the same position like our little view in the scene view is, and at the same angle, so we get the same view. Really helpful instead of trying to like move the camera up there and all that stuff. So let's hit play. We now have a finished character controller. Make sure the speed is like 4, not too slow. W, D, A, S. We can move diagonally by pressing down 2 keys at the same time. We can move around in circles by rolling like that. And there we go. We have a very, very basic character controller. It moves forward. It's kind of it. It just moves forward and backwards and all around. And in the end, the code isn't really that complicated. We check the key, and then we move in the correct direction. The important takeaways here are, using vector to represent direction, because these are just unit vectors, like it's 0, 0, 1. So whatever we multiply it by is going to be like the real speed, right? Because 1 multiplied by x is x. So we're using the unit vector basically for direction, and then this for the magnitude, the actual amount we're moving. And then we're using speed so that we have some control over how fast we're moving. And then we use time to delta time so that we even out the frame rate inconsistency. So yeah, that's our movement. Any questions about this at this point? All right. One problem I've seen people have is they're like, they're looking at their cube and they're like, this is awesome. And then they hit play and then they like, let me move backwards. Let me hold S. Oh, let me also, I need to turn up the speed. Let's go 6. Like that. And like, I'm holding down S right now. I should be moving backwards. And then they're like, okay, let me move left. Let me hold down A. And then their cube starts moving right. So there's a few reasons this happens. There's 2 ways to fix it. The reason that happens is because, remember, the vector 3 dot forward and left and back and right is relative to this cube. This cube has its own forward, right, and up and down and left. It's kind of hard to tell because it's like it's a cube, so all the sides look the same. But it has its own forward. This is its forward. It doesn't care where the camera is. If your camera's here looking this way, it doesn't care. Its forward is this way. So that might look backwards on the camera, but it's really forward. So the ways to fix that are A, move the camera. So that your camera's looking in the correct direction. But let's assume that you built your world, and now your camera's has to be looking this way. Nothing to do is just rotate the player 180 degrees, and you can see that change on the arrows here. We've rotated him 180 degrees. So imagine that you spin around 180 degrees. Now your forward is the other direction. So now his forward is this way. The third and final solution, which you should never use ever, but I'm going to say it anyway so that you know that what you're doing is wrong if you use it, is coming in here and saying, okay, well, W is moving the wrong way, so let me make W move backwards. Let me make S move forward. Don't do that. And the reason is that you're going to get really confused. Because then as soon as something changes, you don't know what's going on. Find a better workaround. And the best one might just be rotating the character 180 degrees, right? Literally, imagine you're walking forward, it's the wrong direction. How do you fix that? Just spin. Just turn around 180 degrees, and now your forward is the right direction. So that's going to be the best solution. Alternatively, you can just move the camera to a better position so that you're looking in like the right direction. Um, then we could do our little Control Shift F. Yeah, there we go. And now our guy's forward is the right direction. Oh yeah, actually that's actually a good note. Um, translate. Okay, so vector3.forward is like an absolute 0, 0, 1, right? It's absolute. It's just a vector. It's kind of meaningless on its own. Translate is what's reading this vector, this direction, and determining what it wants to do with it. It's saying, okay, you want to move 0, 0, 1. And now translate has its own its own code that's saying, okay, move forward, move this direction relative to the player. I believe if you do translate, yeah, that one. So we could do let's copy the code. And then if we do like space world, for example. So by default itself, it means if I say, hey, move forward, it's going to move forward relative to the cube. If I say relative to the world, and then let's say, oh, oops, I probably shouldn't have both at the same time. Whatever. Basically, if I say, hey, relative to the world, it's going to move forward relative to the world. And again, the worlds is these absolute coordinates up here. That means no matter how you're rotated, right? This is forward? No, it's not. This is forward. So that's what you're doing if you're saying relative to the world. The world has some absolute forward, right, and up and down. That doesn't occur in real life, obviously, but in Unity, it can. You can also toggle that, like this little switch up here, local and global. Global is, again, that absolute, like, forward, left, right. Local is our relative X, Y, and Z. And for example, you can see the global, it's locked. The z-axis is along this line and nothing else. The y-axis is up and down. But that can change locally. That might be a little confusing. That can definitely be confusing. But yeah, if you have any questions about that, feel free to let me know. And obviously, if you ever come across any of these issues or any issues in general, you can always ask in the any help channel, game dev chat, help, whatever. All right. So that's kind of the basic of scripts, right? So here we made a script that is running every frame and it's doing something. I'm just going to modify this script real quick just to like give you another idea of what you could use a script for. Just going to comment out everything. How about instead of like a player, we want to make an enemy that just moves forward, just forever moves forward. Basically, to make something like that, we could kind of just skip the whole like if W's pressed because it's an AI, it just moves forward. Do something like this, right? And now if you were to remove the other code, it would look super simple. But this could be an enemy script that you have. It has a speed still, and it just moves forward at that speed forever. And then you'd call it enemy controller and stuff. And what happens now if I run this, run the game, you're gonna see this guy just kind of move forward. Let me adjust his speed up a little bit. There he goes. I'm not pressing anything on my keyboard right now. If I do press anything on my keyboard, nothing happens. So, your scripts can, basically the way scripts work, let me just go over this, is they modify components, right? So if we want to move, we're going to modify the transform component. If we want to draw a thicker line, we would modify the width property of our line renderer. If we want to rotate, we'll change the rotation of the transform. If we want to change the shape of an object, we will change the mesh in the mesh filter. Right? Everything works through modifying these specific properties of components. And your components can, reference your other components. Like if you write a script that you can write scripts that reference your own scripts, like a script that, activates when you step in some sludge, and then it says, "Hey, player controller, set your speed down." And then the player controller sets its speed down because you stepped in the sludge, and then you move slower, right? So all these things are going to work together in the end. So really, whatever you put in your script is going to be modifying your game in some way to get, some different kind of result there. All right. Let's do materials real quick because those are always fun. You can have a lot of fun with materials. Um, and the nice thing about materials is they're very visual. It took us quite a while to get, the script, but when we do materials, you get to see the results right away. So Uni gives us a default material, which is pretty boring. It's kind of just this like white cube. So let's make our own. Um, come back to this project window where we have our script and we have our scenes. And we're going to do create. So right click create. And instead of C# script or C# script, come down. There's a thing called material. It's below audio mixer, below prefab, above lens flare render texture. It's called material. Click that. You can give it a name. I'm going to call it player because that's what it will be attached to. So a material is, you might think of video games as having textures for everything. A material takes that one step further. It's not just the texture. It has a texture, but it also has, basically it's a texture, but then it also defines how we reflect light, which, as we know, light is how we see the world, right? So by changing the way light bounces and stuff, we can change how we, see this object. So let's start by taking our player material, just click and drag onto our player. So you can literally just drag it on. You can either drag it onto the hierarchy, you can drag it onto the scene view, up to you. I'll just drag it here. Then we can test it works by just clicking player here and seeing that the material at the bottom here is whatever we just gave it. Now, no longer the default material that Unity provides. So we come to player, and now we can change all sorts of things about this material. The most obvious one is albedo. Albedo basically is just color. So if we want a solid color, like right now it's just white, let's change it to red. Boom. Now our object's red. Super easy. So if you want to make solid color objects, it's incredibly easy. You just make a material, and then you give it an albedo color, and you're done. You can also define like alpha, but that won't work the way you expect it to. Unless you make it transparent, in which case it kind of works. Yeah, if you make it transparent, you can kind of make glass like that, actually. There you go. Easy glass texture. All right, we're going to keep opaque for now. Yeah. So albedo is our color. If you have a texture, like let's say you have cobblestone.png, right, and you want to apply it to a wall, you'd make a material called cobblestone wall, and then you'd take your image, like your actual texture, right, the 2D image, and you would drag it into your albedo. So unfortunately, I don't. Here we go. So Unity provides some basic images, like default checker gray here, right? Which, notice it kind of gives it the checkerboard pattern. Now, if I had a cobblestone PNG image and I dragged it on here, it would have the cobblestone pattern. And then we can also, kind of remove the color from it, and that's kind of like basically the default image at this point. So if I had a cobblestone image, I could apply it, and you would see the cobblestone image. So albedo, you can think of it like the texture, or in some cases, it might just be a color if you're not using any image. The next two parameters are metallic and smoothness. Now I don't remember exactly how the difference. I believe metallic changes how much of the light comes from the world versus like how much it reflects. So if you have a full metallic value, it's going to reflect all the light, and if you have a no metallic value, it's going to reflect none of the light. And then smoothness changes how much the light is scattered on the surface. So if you have a really smooth, like you can see this preview down here actually is a great place to see. Let's make that nice and big. Here's a non-metallic, not smooth sphere. You can tell the light is distributed super evenly. Like it looks like it's like a matte paint job or something. If you increase your smoothness, you can see the light starts to, not like refract as much. It's becoming very concentrated. It looks like a very smooth sphere right now. It looks like a very, smooth sphere. The light's bouncing. And then you can always play with this. Metallic, I'll be honest, I don't really remember the exact definition. You can always look that up. I believe it's reflecting like the surface more than showing albedo or something. That's findable in the Unity documentation. But really, I mean, in the end, you can kind of just play around with the values until you find something that looks nice. All right. A few more things that you might want to worry about eventually. Normal map. So you might have heard of normal maps before. You might not have. Um, Basically, what normal maps allow you to do is to have, say, a cube, but then give it what seems like a texture that's bumpy. So, for example, cobblestone. Actually, let's see if I can find an example of a cobblestone normal map. Cobblestone normal map. Here we go. So here's what a normal map looks like. It looks really weird. And what it basically is it's defining the shape or what it's called the normal of the wall. So the colors are basically just a way to encode a vector, which is pointing outwards. So if we think of something like a sphere, right? If you take any point on the sphere, the normal or the vector that points out is going to kind of like curve around the sphere. It's not always going to be pointing in one direction. If you have something like rocks like this, see that you can notice the bottom of every rock has like the same color. It's kind of like teal greenish. Can I zoom in more? I'll just zoom in real nice. There we go. The bottom of every rock has the same teal color. And now I'm just going to assume, just that teal color corresponds to a vector that's basically pointing downwards, basically telling the light that this is, the light here should reflect downwards. And then this kind of darker purple up here is telling it, hey, reflect upwards. So what you're doing is your cobblestone wall isn't actually going to have a shape. It's just going to be a cube. It's just going to be a sphere, whatever. But because we can change the way the light reflects off of it, if we let's try this. Let's see if I can just bring it into Unity real quick. That would be really nice. I might be able to. Normal. Let's go. There we go. So notice that it. Let me try to turn this down so it's a little easier to see. That actually be the easiest. Actually, you can see it really easy here. It looks like it's 3D, kind of. There's no actual 3D like object. This is just a cube. So in terms of like rendering and physics, it's really easy. It's just a cube. There's no like little shapes that are getting us caught up. But it looks much more 3D than it would, otherwise if you just had an image. If you have a flat image, it'll just kind of look, it'll look like a flat image. But when you add the normal map, you can get kind of a little 3D effect going on. That's pretty cool. And it's also not as expensive to render as modeling out a 3D wall. So that's really neat. Texture is not marked as a normal map. Fix. I don't know what that did. All right. Oh, there we go. Now it knows it's a normal map and stuff. All right. Height map is kind of the same thing, except different format ish. Yeah, I think you can modify the shape a little bit more with the height map. I'm not too familiar. Then occlusion, I believe, is just the way light doesn't reflect. So you can set like it's a little bit more complicated. Not too familiar with the occlusion map, but that's one thing you can do. The last one I'll talk about is emission, which is basically you can give it like a color to emit. So notice it just kind of makes it brighter, but it's almost as if it's glowing. So like that. It'll make the texture parts around that are glowing, they'll make them brighter as if it's glowing. Won't actually emit any light, which is good because that's expensive if you have a bunch of lights. So it's kind of like the cheap way to do lighting. If you want actual lights that's gonna like shine on the environment and stuff, you're gonna want to put a light. You want like a point light right there. And then also with the mission, what you can do is give it a map, which looks similar to the normal map, except it's all black and white. And it will change. If it's white, it will emit a lot of color. It'll like look like it's glowing very bright. And if it's black, it'll look like not be glowing at all. So if you had your gun with had some like tubes that like glow, um, you would get an emission map that looks basically like it's the same like shape as the texture map, except everywhere you don't want to glow is a black pixel, and everywhere you want to glow is some shade of gray. The brighter, so closer to white, the more it's going to glow. The less it's going to glow. So textures and materials really are a way to make your game look really good, really fast, as long as they're made well, obviously. I'm not too familiar with ways to actually like produce normal maps, but I'm sure there's ways to like export. I'm sure if you modeled something like this in Blender, you could export it as a normal map around a cube or something like that. And then at that point, you drag it into Unity, and you go from, you know, lame, stupid cube to like cobblestone cube in like 2 seconds. And that will really just elevate the way your game looks for like super cheap. And again, this isn't even like a super complex model or anything. This is a cube. And for physics, it will act like a cube, which is good because I don't want the player to be able to find out that there's one rock that's a little bit higher than they can jump on it and then go past a wall. So that's what's really nice about materials. They're going to change the way our game looks significantly and just make our game a whole lot better. All right. At this point, I think I'm kind of done with everything I wanted to cover. Tomorrow's going to be, or not tomorrow, next time is going to be physics and more scripting. So like jumping with the character and stuff. And then also probably collisions. And that'll probably be it for the very basics of the Unity tutorials. Everything to follow after that will be um, little mini games that we eBoard make. Um, and then we'll be using concepts like the ones here with like scripts, and we'll be using materials, and we'll be using all that stuff to kind of give a reason for like why all this stuff exists. We'll basically be using everything that we talked about, and then some other stuff in a really simple way to create a simple game that you can then look back on if you're ever like, oh, they use the line renderer for bullet trails. Okay, how do I use the line renderer? So if you have any questions about either what we did today, or what's going to be going on next week, or what's going to be going on in the future, um, yeah, feel free to ask. Other than that, I don't think I really have much other stuff for you guys. So, or if you want to see anything real quick, if there's anything that you're like, oh, how does this work, or can you do this real quick? Also, feel free to type in VC text chat if you don't want to speak. All right. If there are no questions, then that's it from me. I hope you guys learned a lot about just kind of the basics of Unity. We talked a little bit about what each part of Unity is, what components are, which is pretty important to have good understanding of. How scripts fit into all that, kind of what scripts can do. They can modify other components, and then also how we can use materials to change the way our games look. All right, I'll see you guys next week. I'm going to end the
Awesome. Thank
recording
you
here.
guys.